All right, for homework number 11, we're starting out where we need to find f prime of x and then f prime of c. And you could do product rule on this, but then if you want to simplify it, things get kind of ugly from there. So I'm going to FOIL f of x together first. So distribute the x to the third all the way through. So this is 3x to the fifth plus 2x to the fourth minus 5x to the third, and then distribute the 4x through, so that becomes plus 12x to the third plus 8x squared minus 20x. And then I'll combine like terms. So 3x to the fifth plus 2x to the fourth, and then we've got minus 5 plus 12, so plus 7x to the third plus 8x squared minus 20x. All right, and then so this is just f of x still. And then make sure that you don't just put in equals when you start taking the derivative. Call it f prime of x. We don't want to have false equivalences. So this is 15x to the fourth plus 8x to the third plus 21x squared plus 16x minus 20. So I have f prime of x, found that, so that's one answer. And then we are also supposed to find f prime of c. In this case, c is 0. So that's really easy. If you put 0 in for all of these x's, all of those terms will become 0, and we'll just be left with negative 20. So I'm going to box these in together. All right, so that's our first problem. 16 and 17 have the same instructions, find f prime and then find f prime of c. So I can't do anything to simplify f of x. You can't divide individual terms or anything. So we're going to have to use quotient rule on this rational function because it can't be divided out. So quotient rule is low, d high, derivative of the top. I still write the ones even if they're 1, just so I know I've done that. So low d high minus high d low, the derivative of x minus 5 is 1, all over low low, which is supposed to mean x minus 5 squared. And then we clean up what we have. So these ones, I didn't necessarily need them. So this is x minus 5. Remember to distribute a negative through, minus x minus 5. So f prime of x is negative 10 over x minus 5 squared. So that's my f prime of x equation. And then we're supposed to find, for this problem, f prime of 4. So if you plug 4 into this, negative 10 over negative 1 squared, f prime of 4 just becomes negative 10. Be careful on problems like 17. It's tempting to want to say f prime is 1 times sine x, but this is a product. So I like to remind myself by putting parentheses around here. So f prime of x, I have to use product rule, which is first times derivative of the second plus second times derivative of the first. So we can clean that up. F prime of x is, I would just make this negative x sine x. This is just plus cosine x. So there's f prime. Evaluate f prime at pi over 4. So that gives us negative pi over 4. Sine of pi over 4 is radical 2 over 2. Cosine of pi over 4 is also radical 2 over 2. Okay, and I'm going to work on simplifying this a lot because not that you have to simplify it this much if it's a free response question, but if you're looking for your answer in multiple choice, they usually do a bit of work to combine terms for multiple choice answers. So what I mean by that is this is going to be negative pi radical 2 over 8. And then maybe they would adjust this. So like this radical 2 over 2, maybe they would make this over 8. So you could say, okay, that's negative pi radical 2 plus 4 radical 2, and now it's all over 8. But then they might take it one step further too. I can combine like terms up here because I have radical 2's. This is what, remember Mrs. Meckley stopped in our room and asked us, do we have to do this? So maybe we should have told her yes. Not that we have to do this, but we have to recognize that if we see this multiple choice and we left our answer back here, we have to recognize that they're equivalent or that we can work on it and simplify it. Okay, number 24, rewrite, differentiate, and simplify. Now, I do want to rewrite this. You don't want to use quotient rule if you're dividing by a single number. And also, this isn't even, if it's just a single term, you would want to divide everything by that term. So whether it's a number or a variable down there, I would rewrite this so that it's like y equals just 5/11 x squared minus 8/11. So when I differentiate, when I find dy dx, I'm using power rule here. So 5/11 times 2 is 10/11, and then it would just be times x. And the derivative of a constant is 0. So because I wrote the plus 0, I'll simplify this. So just 10/11 x is our final answer. And so that's why it says without using the quotient rule. You really shouldn't. The quotient rule would work because the derivative of the bottom is 0, but it's silly to do all that work. Okay, find the derivative. We're doing number 26. So here I can't divide anything out because I have two terms down here. So I've got to just do quotient rule. So quotient rule is low, d high, derivative of the top is 3x squared plus 5, minus high, d low, derivative of x squared minus 1 is 2x, all over low, low, so the bottom squared. Now, can we leave our answer like this? Well, if it's a free response question, we're going to be doing more with it. We're going to be setting this equal to something. So yes, we need to keep going. If it's a multiple choice answer, they're not going to leave the answer in quotient, in the quotient rule format. So yeah, you need to be able to simplify this. It's complicated, but you need to be able to do stuff like that successfully without just being like, oh yeah, I made a dumb mistake. So try to practice this, and I'll see if I can do it without making a mistake too. So I'm going to distribute through, take the x squared through first. So that's 3x to the fourth plus 5x squared. And take the negative 1 through, minus 3x squared minus 5. Now here, there's a minus and a 2x out here. So I'm just thinking to myself, I'm going to distribute a negative 2x through all of these terms. So this becomes minus 2x to the fourth. Negative 2x times 5x is minus 10x squared minus 6x. And then I do not want to combine terms down here. Remember, when you're working with a rational expression, if you're trying to simplify it, the ultimate goal is to distribute and combine terms in the top to see if you're left with something that can factor to cancel with factors in the denominator. So I don't want to go foiling this out. All right, so what do we have left? We have 3x to the fourth minus 2x to the fourth. So x to the fourth. I don't see any x to the thirds. I have a 5x squared minus 3x squared, so that's 2x squared. Minus 10x squared is minus 8x squared. Positive 2 minus 10. There's a minus 6x, and there's a minus 5. And this is all over x squared minus 1 squared. Now this is where I stop because the next step would be, oh, maybe I can factor by grouping. Factor by grouping does not work in this scenario. Also, it's not going to give me anything that gives me an x squared minus 1 factor. So that's as far as I'm going to take that one. All right, now number 35, I left my work here because this turned out to be pretty crazy. In our notes, we had the rule for what do you do if you have 3 things multiplied? And so basically it was this. You could do this in any order. It was, here's what I did. Derivative of the first, so that, times the other 2 left alone, so I just multiplied them. And then I did derivative of the middle, so derivative of x minus 3 is 1. And then I multiplied 2x to the third plus 5x times x plus 2. So I got that. And then the final term is the derivative of the last piece, which is also 1. And then I multiplied these two parentheses together. I did this just because on the first version of the key, I didn't. So I was looking to see how it came out. And it came out pretty terrible. So this did not save me any distributing. So it would be better if you distribute f of x at first. Like, just make it 2x cubed plus 5x times multiply these two together because they're easy to do. And then just distribute this. So 2x to the 5th minus 2x to the 4th minus 12x to the 3rd. Then I'm taking the 5x through minus 5x to the 3rd. Oh no, plus 5x to the 3rd minus 5x squared minus 30x. So what does that leave me with? That leaves me with 2x to the 5th minus 2x to the 4th minus 7x to the 3rd minus 5x squared minus 30x. If I take the derivative of this, do I get this f prime, 10x to the 4th minus 8x to the 3rd minus 21x squared minus 10x minus 30? Yes. So this is definitely the faster way to go. FOIL it, power rule, and then get the answer. And I did that on the very first problem too. I distributed, power rule, and carried on. And it's almost always going to be easier when everything's a polynomial. Okay, 39. Find the derivative of the trig function. So remember, especially with trig, people are tempted to say, oh, it's just derivative of this times derivative of this. But you have a product of two types of functions. So we need a product rule here. So it's the first times the derivative of the second plus the second times the derivative of the first. And then you just clean up what you can. It's not much to clean up. T squared cosine t. I always put trig functions at the end so that I don't think something's in the angle. So I'm going to say plus 2t sine of t. You can also put parentheses around your angles if you like that better. That doesn't matter. But yeah, that's it for that problem. Okay, I have this little warning over here. We're going to be using a trig ID at some point. So let's look at f of x for 43. So the derivative of each of these terms, f prime of x. The derivative of negative x is negative 1. The derivative of tangent x is plus secant squared x. And maybe you leave your answer like that, but maybe you don't see that answer in the multiple choice section. So you are expected to know the 3 Pythagorean trig identities. And the one that involves secant squared, the original that we learned last year is tangent squared x plus 1 equals secant squared. Hold on, the pen just ran out. So here's the original trig identity that we learned in pre-calc. And so all that they have is if you solve this for tangent squared, you get secant squared minus 1. And that's what this is, negative 1 plus secant squared. So actually this f prime x is also just tangent squared x. So again, you are expected to know those Pythagorean identities, and they will have tangent squared as an answer in multiple choice rather than maybe secant squared minus 1. Okay, for this one, g prime of t. So remember, this is t to the 1/4. So when I do power rule, it's 1/4. T to the 1/4 minus 1 is negative 3/4. And then the derivative of cosecant, it starts with a c. So the derivative is going to be negative. There's a 6 in front. So the derivative of cosecant is negative cosecant t cotangent t. Here's where I would put parentheses around my angle just so it doesn't look weird. And then the only thing to simplify this really is getting rid of the negative exponent. But cosecant times cotangent, nothing cancels. That's 1 over sine times cosine over sine. If anything canceled with those, I would simplify that, but otherwise I'm just going to leave this. Oops, cosecant t cotangent t. All right, so that's the answer for that g prime. Evaluate the derivative of the function at the given point. Use a graphing utility to verify. So f of x is tangent x times cotangent x. Now you could start going through a whole fun product rule because we're finding a derivative. But remember, with the original function, you're allowed to work on the original function algebraically. Think about tangent times cotangent. Those are reciprocals of each other. Tangent x times cotangent could be 1 over tangent x. So this function actually just looks like the horizontal line that goes through 1. And the only stipulation here is that tangent x can't equal 0, because then you would have an undefined value for cotangent here. So that just means that like x can't equal 0, pi, 2 pi, 3 pi, or whatever, k times pi, if k is an integer. But they're not asking us to plug in a multiple of pi. They're asking us to plug in 1. So what is f prime of the constant function? It's equal to 0. So f prime of 1 is also equal to 0. And if you want to verify in your graphing calculator, make sure you're in radian mode. It would be tangent x times 1 over tangent x. I don't know why I'm in the second line. And then I would just zoom 6. So see, it just looks like a horizontal line. If I ask it what is the value at, what did I say, a multiple of pi, right? So what's the value at pi? See how it has no answer for the y. So that's how the calculator says undefined. Or if I went to the table and found pi, it would say error. All right, but the derivative at 1, not pi, the derivative at 1 is 0. All right, for 65, part A is find an equation of the tangent line. So remember, to do that, you need a point, which is given to us, and you need a slope. And to find the slope, that means that you need to find f prime of negative 5. So that means we need an f prime equation. Remember, you cannot divide. This looks like an upside down heart. That means it's bad. We can't divide each term like by the separate x and the 4. So we have to use quotient rule to find f prime of x. So it's low, d high, minus high, d low, all over low, low. Simplify that. X plus 4 minus x is just 4 over x plus 4 squared. And then we are supposed to evaluate the derivative at negative 5 because that's just going to find the slope for us. So when I plug in negative 5, I get 4 over 1, which is 4. And remember, find an equation. So write the equation. So y minus 5 equals slope 4 times x plus 5. That's my tangent line equation. And then I'm not going to type this in again, but I typed the expression into my graph. I typed this equation with the plus 5 on the right side, typed that in, and I can see that, yes, at negative 5, it looks like this is a line that's tangent to the graph. And then remember, our calculator calculates using that like parallel secant thing. So it's not telling me exactly 4, but rounded to 3 place accuracy, the calculator agrees that the derivative is 4 at that point. Okay, same idea for this one. So we need to find the tangent line equation to the tangent graph. So f prime of x, the derivative of tangent is secant squared x. When you are evaluating at pi over 4, remember with trig functions, secant squared means what's the secant of pi over 4? Take that answer and square it. All right, so we know cosine is radical 2 over 2. If you remember from your speed quiz days, if you simplify 2 over radical 2, you get just radical 2. So that's a good one to know so that you don't have to go through all of this work. So this is just radical 2 squared, and that is 2. So if that's the slope and I've got the point, I can say y minus 1 equals 2 times x minus pi over 4. So there is my tangent line equation. And then I've graphed tangent x, and I've graphed the equation for this line. I put the plus 1 on the other side. And yep, I can see that at the pi over 4, we're estimating where that is. I see a line that looks tangent to that curve. Oh, and then at part C, ignore the top line because that was from the previous problem. I do get a slope of 2. Okay, we had this problem, and I forget if it was homework 10 or I think it might have been homework 9, actually. So determine the points, which means we're going to need x, y coordinates, at which the graph of the function has a horizontal tangent line. So this is almost guaranteed to be, something like this is guaranteed to be in your free response if it's anything like previous years. So horizontal tangent happens when the slope, f prime of x, is set equal to 0. So first we need an f prime of x equation. And I can't simplify this at all, so I'm going to start with quotient rule. Low d high minus high d low all over low low. We need to simplify this, so I'm going to distribute the 2x through. I get 2x squared minus 2x. This is really just minus x squared. Remember, we don't usually distribute in the denominator. This cleans up a bit. This is x squared minus 2x all over x minus 1 squared. So here's my f prime of x equation. And then, like I said, we're looking for horizontal tangent points. So we need to set this equation equal to 0. And I'm going to factor an x out of the numerator. So this is now just a rational equation. So think back to your pre-calc and your algebra 2 days. A fraction, a rational function, is equal to 0 when the numerator is equal to 0. So that's just at x equals 0 and x equals 2. The denominator is only there to remind you that, hey, x equals -1 is not, or +1 is not a possibility here. So, but that's not one of our zeros anyway. So these are the 2 x coordinates, but remember, you're not finished because it says determine the points at which the graph has a horizontal tangent. So now that I know the x coordinates, I have to go back and say, what is f of 0? So go back up here. 0 over -1 is 0. And what is f of 2? 2 squared is 4. 4 over 2 minus 1 is 4. So the horizontal tangent happens at 0, 0, and there's another one at 2, 4. You could confirm both of those points by graphing this and finding these points and seeing, does it look like there would be a horizontal tangent? That would happen if there's a relative max or min, or maybe if the graph has like a flat part to it like that, going from concave down to concave up. All right, last 2. Here's another like really common AP question, usually a multiple choice, sometimes part of a free response. So they don't give us an equation, but the goal is to find f prime of 2 given this information. All right, so f of x is equal to g of x over h of x. They're trying to trick you into saying, oh, that's just f prime is g prime over h prime, and divide them out. But we know you have to do quotient rule. So it's still the same little rhyme that we have, low d high minus high d low, but just apply these functions. So low d high would be, derivative of the top would be g prime of x minus high d low all over low low, h of x squared. I'm using brackets just to distinguish what I have there. And then we want f prime of 2. So put 2 in for all of those inputs. I think it's worth writing this part, by the way, because it's easy to get kind of mixed up in what you're looking for, and it's nice to have it just clearly written on your paper. And then sub in the numbers. And when you do that, put them in parentheses so you don't screw up positive and negative signs. So h of 2 is -1. G prime of 2 is -2. There's a minus sign right here. G of 2 is 3. H prime of 2 is 4. H of 2 is -1. And then that's going to get squared. So this is 2 minus 12 over 1. So f prime of 2 is equal to -10. All right. Last one, I think, is 108. So g of x times h of x. So again, I have to remember that there's a product rule for this. So the product rule is first times derivative of the second plus second times derivative of the first. And then we're supposed to find f prime of 2. It says that in the directions. So I'm just putting 2's in for the inputs. I don't think that that is necessarily required, but I mean, you could just say f prime of 2 equals and start putting the numbers in. I like to have this so I don't make a silly mistake, or I'm less likely to, I should say. Okay, g of 2 is 3. H prime of 2 is 4. Plus h of 2 is negative 1. G prime of 2 is negative 2. 12 plus 2. F prime of 2 is 14. All right, so that finishes homework assignment number 11. Please let me know if you have any questions.